So now we're going to talk about the mean and the average, the median. The book has some pretty good examples on in section two. You know, they're kind of entertaining and it shows you some different things. It wouldn't hurt you. It'd be good for you actually to look at some of those and kind of get an idea of what's going on here. Um, there's a lot in section two. I'm not going to go all over through section two. Instead, I'm going to highlight some of it. But basically, um, let's just start with some numbers. Let's say these are test scores out of one of my classes, 50, 55, 57. So I'm just making these up in my head. Um, they aren't really true. They're just me writing down some numbers because I need some numbers to work with. Okay, so I start writing some numbers down. Um, got quite a few stacked right around this area, and then start kind of all right, so we have these numbers. There's a lot we can do with these numbers. I've put them in order for you already, in order from the least to the greatest. Um, there's an online calculator. I probably ought to send you the link because with the calculator, it makes it so much easier to do this. So I'll send you a link with an online calculator, and I'm just going to use it right off. Actually, I'll do it by hand. So the median is the middle. So if I start counting off from end, so one, and then I'm going to mark two off to make it go a little bit faster, and then I'm going to mark three. Just let's see, there were three more, three more. So I'm just working my way into the middle. Okay, then one, and then one. There's my middle number. Okay, so 81 is my median. Okay, so if I were to put these in order, that would be the median. Now, find the average and all that other stuff. I'm going to just type it into the calculator. Like I said, I'm going to have to send you a link so that you can um, see what it is. And let me go back. Huh. So I'm going to write all of those numbers down in just a second. So what I'm going to do is I'm going to go to my calculator. There's an app that says a button that says stat. So I hit stat and I hit edit. Okay, and I'm going to come over here to list one. And I'm going to move it up to list one, and I'm going to hit clear. And I'm going to hit enter. And it clears all those off. Now I'm going to type in all of those numbers. So I'm going to type in 50, and then 55, and then 57, and then 61 twice, and then 63, and then 67, and then 68, and then 71, 73, 75, 78 twice, then 81 twice, and then 82, and then 83 twice, and then 84, 85, 88, 89, 91, 93, 97, 99, and 100. Okay, so there's my list of numbers. Okay, so I've got these numbers. I'm going to scroll through real fast, make sure I don't have anything that looks way off. I'm going to move over to L2 and clear it off. Now what I'm going to do is I'm going to hit the stat button again. And in the middle of that, it says calc, which means calculate. And I want to do one variable stats, and so I hit enter. Okay, so I hit one variable stats. I'm going to use my list one. I'm not going to put it anywhere, and then I'm going to calculate it. Okay, so that brings up a whole list of numbers. So when that brings up that list of numbers, that's everything that we're really looking for. And I'll explain what some of these numbers mean in just a second, but I'm going to get my highlighter so I can talk about them. So this one with the X bar, that's our mean, or our average as most people like to call it. But that's really our mean, okay? So that's the average. You've talked about average your whole life. So we're going to write that down. So my average is 77.52. So that's my mean, okay? The next one that we're really going to look at is this one. And that's called the standard deviation. Okay, this little notation when you see it, that's standard deviation. Okay, and I'll talk about what that is as well. And now if I look right here, it says minimum is 50, quartile 1 is 67. And then if I scroll down, it's going to bring up some more numbers. It says my middle number is 81, which is the same thing we got. Quartile 3 is 88. And the max is 100. So there's a lot of numbers right here that you're like, this is clear as mud for me, you know? What do any of them mean? So let's talk about them and give you some information to what they stand for. So I've got those numbers. I've kind of erased the calculator stuff so I have some room to write. So the mean is if we, here's the easiest way to describe the mean. In this case, the mean and the median are the same. But notice the numbers below 5. If I go 5, 3 minus 5 is negative 2. 1 minus 5 is negative 4. And then 7 minus 5 is 2. 9 minus 5 is 4. If I add these together, that's not what I wanted. Well, the difference away from the mean, if I add that together, will always be 0. So that's a great thing to know, that the mean, the amount above and the amount below is always going to be 0. So that's what the mean kind of stands for. It's like, where is the middle number, so that if I go above it by whatever is here and I go below it by whatever is here, when I add it together, I get that's the middle. There's the same amount above as there is below as far as if we go off of the mean. Okay, so it's the average. So that's another way to think of the average is there's the same amount above this number as there is below this number. So there's there's 6 above and there's 6 below this number. So like 1 is 4 below, 3 is 2 below, there's 6 below, 7 is 2 above, and 9 is 4 above. So there's 6 above that number. So that's what the mean means. It's kind of like we have the same, it splits the number above and below that is always going to be the same. Okay, so when I talk about the mean, that means there's the same amount of stuff above and the same. So if I have my data, it splits it right in half. There's the same amount of numbers above this as there is below it. Okay, now we'll come back to this standard deviation here in a minute, but let's talk about this stuff. This stuff breaks it into quarters. Okay, they're actually called quartiles, but it breaks it into quarters. So it breaks it into 4 parts. Okay, so if I had a number line, and my smallest number is 50, so I jumped from 0 to 50. And I'm up here at 100 for my maximum number. In the middle is 75. So right about here is like 80, and about here is 70. About here is 90, and about here is 60, something like that. So minimum, we're going to put a line. So not a line, a dot. So the minimum and the maximum, we put dots. Okay? And then these three, we're going to put a line. So 67 is about right here. 81 is about right here. And 88 is about right here. What this makes is a box and whisker chart. Okay? And what it means is 25% of my numbers. So you know how we had 27 numbers? And I should have done 28 because I'll show you what 28. A fourth of 28 is 7. So this would have 7 numbers all the way through. Now on ours, one of these is going to be 6 because we're one short. So we're going to have like 6, 7, 7, 7, or 7, 6, 7, 7, something like that. Okay? But that's what this means. A box and whisker chart, it breaks our numbers into quarters. Okay? So if we wanted to say it this way, it'd be like, here's my A's, here's my B's, here's my C's, everybody down here got D's. You know, I mean, that's 25% of you got D's, 25% of you got C's, 25% of you got B's, 25% of you have A's. Okay, and that would break it down evenly so that every 25%, okay? So that's a box and whisker. It breaks it down that way. And I can tell that there's a pretty big chunk of numbers right in here because see how tight this is? Okay, so between 81 and 88, I have 7 numbers. So that's a pretty tight area versus this is very spread out because it takes me from 50 up to 67 to get that far, to get 7 numbers in there. So this tells me that most of my people are, or a tighter amount of my people are in this area, okay? So these guys scored, there's a cluster group more up high than there is down low. So that's an easy way to look at it. The box and whisker does a better job if you have numbers that are way spread out, like outliers. So if I had like a 10, you know, if somebody would have got a 10 on their test, then this would have been down here to 10, you know, and this would have come all the way down to there. But it doesn't change, the median doesn't change a whole lot with just one outlier versus with the average, with the mean of, if I'd have thrown the 10 in there to calculate the mean, it really would have pulled it down. And so we would have said it was skewed down, or on our number line, that is to the left. Okay, so actually, I have that backwards. Okay, we'll talk about skewed in a second when I can draw a better picture. So anyways, that's the box and whisker, that's the quartiles, and that's looking at it that way. So that's what this information is important to use, is that quartiles, and your calculator will get that for you. And you can download a calculator just like what I have on here onto your computer. So it's a free app. You guys can get it, and it's pretty nice. I've got it on another computer and seems to work pretty well. Now, the next one we're going to talk about is our standard deviation. And that goes with what's called the normal bell curve. Okay, we're just going to jump right into it. So standard deviation, deviate means how far you go off. Like if you're walking on a trail, this is you, you're walking on a path. Okay, and the path comes along like this and then makes a little curve. Well, you're closing your eyes and you come off the path. You're no longer on the trail. Okay, you have deviated. So what we want to know when we talk about standard deviation is how far off of average are you? Okay, so, whoops, I don't want to erase that one. So how far off of average are you? Okay, that's what standard deviation stands for. So a person of 81 is not off very far, but a person of a score of 100 or 50 they're off a long ways. This one of 50 is off by 27.52. This score of 100 is off by 22.48. Okay, so these two scores are off of the mean by quite a ways. So that's what standard deviation is. So that's the deviation. Now standard means, let's break this up into standard chunks. Okay, so on our bell graph, this is always the mean right here. Okay, and then what we do is we have one deviation above. So if I added 13.5 to that, I'd have 2, 0, carry the 1, 10, 11, 8, 9. So this would be 91.02. That would be one deviation above. We use that little symbol for standard deviation. So that's one standard deviation above. Okay, we've gone up one standard deviation. Now if I add another 13.05 to this, or 13.5, I'd get 52 for 104.52. Now realize we can't get it that high on the test, but that's my next spot. That would be two deviations above. So that's two deviations above my average. Okay, now if I go below, I'd have 77.52 minus 13.5. That's a 20460. So 64.02. And if I go below that by another 13.5, borrow here. So 2, 10 minus 5 is 5. 3 and 3 goes away. 50.52. Okay. So now we would, if we were to look at our numbers, so we had a test of 50. I'm just going to put a little X on here for each of those tests. We had an X of 50, which is in here. We had a 55, which would be like in here, a 57, a 61, a 63, a 63, a 67, a 68, a 71, 73, 75, 78, 78, 81, 81, 82, 83, 84, 85, 88, 89, 91, 93, 97, 99, 100. Okay, so that breaks my data down that way. So it breaks it down by median, by the mean, and the standard deviation. So we can calculate like how much of a standard deviation off you are and stuff like that. But the important part of this is to realize that half of my people are below and half my people are above. Okay? Now, even more interesting is that 95% of my people, if it's a normal bell curve, 95% of my people are within 2 deviations of the mean. So they're 2 deviations above or below. 95% of my people are in there. Okay, standard bell curve. So negative 2 deviations below to 2 deviations above. Is 95% of my people. Okay, and then the middle two, just these two, is 68% of my people. So just 1 deviation below to 1 deviation above, 68%. And if I go 3 deviations, that's 99.7% of my people. So I had 3 deviations. If you lie outside of 3 deviations, you are statistically way out there. So like when you get your ACT test, it says you are this many deviations above or below or whatever the normal for the people that took this test. So if you're one above, you're sitting right here. You know, you're sitting on this line, and you could say, okay, I'm right here. So this is 50%. So half of 68 is 34 and 34. So this line's like 84%. So you're in the 84th percentile. You know, you're up here in the 84th percentile. All these people scored lower than you. These people scored higher than you. Well, if you're up in this range, you are phenomenal. You're out there. You're weird almost because you're way outside of normal. Like you're outside of 3 deviations. If you're way down here, it's like, um, did you sleep through the whole ACT, or is there something going on with your mind type thing? Is it not connecting the wires correctly? Okay, up here it's like the wires are connecting correctly. They're connected so well that things run fabulous. So anyways, that gives you a quick idea of the standard deviation. This 68, 95, 99.7% rule is very important. Okay, so this is one deviation above and below. This is 2 standard deviations above and below. This is 3 standard deviations above and below. And that kind of talks about all these things. Okay, now if our curve looks something like this, so notice that this is not a normal deviation standard belt curve. Okay, and neither is this one. I'll make it even more. Whoops. Here's normal. So if you think of this as like a tail of some elephant, like here's your elephant, you know, he's got a long nose, got a tusk and a head and a body. Woohoo. It's like a snail or something. I don't know what it is. But anyways, boy, that's a horrible picture. But anyways, you kind of hopefully get the idea. Well, whatever way you can pull on the tail, if I pull on the tail to the left, it's skewed left. Okay, that means, you know how I was talking about the data down here? If I had like a number 10, it was pulling the average, is pulling the average this way. You know, it's pulling the mean, instead of being over here, it's pulling the mean down. Whereas this one, there's some high numbers, they're pulling the mean up. Okay, so instead of it being reflective for what it really is, this is pulling the mean down, this is pulling the mean up, because these are high numbers. It's kind of like if everybody on the test got like an 80, and then there were 2 people that got hundreds, that got 100%. These 2 would pull the average up. Okay, and on this one, let's say that everybody scored like 80, 90, you know, in the 70s. And then we had people down here that scored like 5, and another one that scored like 8%. These 2 pulled the average down. So that's why it's skewed left, because these guys have pulled it down. This is skewed right because these few people have pulled it up. So anyway, that's a quick idea about skewed. Okay, so that's what skew means, is it's been pulled up or pulled down. Now, normally we don't have a standard bell curve. What we normally get um, from our data, we normally collect our data and make a histogram. Okay, so there's a whole lot of uh, weirdness in going about making a histogram, but we know what the mean is. The mean was, I knew what the mean was. So the mean 77.5, right? Well, the histogram doesn't necessarily even use the mean. What it does is let's just break it up. Let's count by, let's go groups from 49 to 54. So we're going the length of 5. So you'll have something like this, and I'm not going to expect you guys to make one of these, okay? Uh, or if I do, I'm going to give you all this information. 49 plus 5 is 54. 55 plus 5 is doing something wrong here. I want this to be 59 and 69. I want this to be 59. There we go. So if I add 4, I get to 53. And I go 54. If I add 4, I get to 58. If I add 4 from 59, I get to 63. So 68, 69, I add 4 to that, I get 73. 74 to 78. Now we're rolling along. Normally we wouldn't have this many lines on our histogram, but for today we do. Okay, so that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But anyways, what we're going to do now is we're going to find out how many numbers there are between 49 and 53. So 49 to 53, this is the only one, so there's 1. 54 to 58, 55 and 57, there's 1. 59 to 63, so 61, 61, 63, there's 3. 64 to 68, 1, 2. 69 to 73, 1, 2. 74 to 78, 1, 2, 3. 80, 79 to 83, 1, 2, 3, 4, 5. 84 to 88, 1, 2, 3. 89 to 93, 1, 2, 3. 94 to 98, 1. And 99 to 103 is 2. I probably ought to do a little smaller histogram. Let's do 8. 49 plus 8 is 57. I'll hurry and come up with these. There, that works a little better. 49 through 57. So 1, 2, 3. 58 through 66. 1, 2, 3. 67 through 75. 1, 2, 3, 4, 5. 76 through 84. 1, 2, 3, 4, 5, 6, 7, 8. 85 through 93. 1, 2, 3, 4, 5. And 94 to 102 is 3. So now if I make a histogram, that's like a bar chart, okay? So we're going to skip a whole bunch of numbers. And on our bar chart, most of the time they'll put a number like 48.5. And so they'll start with like 48.5. And then they'll say 57.5. And then 66.5. And then 75.5. 84.5. 93.5, and 102.5. So the numbers between 48.5, and then over here they'll say how many there were in that area. So in this area, there were 3, so I'd go up 1, 2, 3. In this one, there were also 3. And then in this one, there were 5, 6, 7, 8. This one, there were 8. This one there were 5. And then in this one there were 3. So you can see it kind of follows a bell curve shape. That's normally what we're looking at. Most of the time we don't have this pretty bell that pops up. Instead we're saying that looks normally distributed, okay? So maybe it's skewed a little bit to the left, but that gives us an idea of, of what we have here. So that's a histogram. So it's telling you how many numbers are between 48.5 and 57.5. It doesn't actually tell us what these numbers are. So that's what we'll have to work with. So anyways, that's kind of a crash course in statistical data. You know, the bell curve, the mean, a box and whisker, a histogram, lots of stuff in here. I mean, that's a pretty big crash course unit on that. And there's one more thing we could do with these real fast. Let's show you what a stem and leaf plot looks like. Okay, a lot of people like a stem and leaf plot. So we have a stem and we have a leaf. So here's our stem and here's our leaf. So here's our root number. These are in tens. So that means I have 5 tens, which is 50. The leaf is 0, and then I have a 5. That means 55, and then I have a 57. So that's 50, 55, 57. Then I jump to my sixes. So I have 61, 61, 63, 67, and 68. Then I jump to my 70s. There's a 71, 73, 75, 78, 78. Then I jump to my 80s. There's an 81, an 81, an 82, an 83, an 83, an 84, an 85, an 88, and an 89. Then I jump to my 90s. There's a 1 and a 3, a 7 and a 9, and then I jump to my hundreds. Okay, so that's a stem and leaf plot. You've done those before. It's been a while, but that's a stem and leaf plot. So now let's go ahead and work on question number 1. It says, here's a histogram. Let me hurry and draw it. So this is kind of the picture. It's not the best. This is about what I could figure based on their lines. This one up to 25, this one up to 41, this one up to 39, 27, 24, 22. What that means is between 0 and 10, there were 25 scores, or the number of emails per day. So there were 25 people who had 0 to 10 emails. There were 41 people who had 11 to 20 emails. There were 39 who got 21 to 30 emails. 27 people got 31 to 40. 24 people got 41 to 50. 22 got over 50. Okay. Estimate the mean and the median number of messages received. So again, I'm going to show you how to do this on a calculator the easiest way. The easiest way that we're going to do, and this really should be a 1, but what we're going to do is find the average of these numbers. Okay, so from 1 to 10, 0 to 10 is 5. The average of 11 and 20, if I add those together, is 31. And if I divide it by 2, I get 15.5. If I average those, I get 25.5. If I average these, I get 35.5. So 91, half of that is 45.5, and then somewhere over 50, we don't really know, but we'll just put like 55.5, okay, because we don't really know, so we're just going to say 55.5. So what we have is we have 25 people that averaged 5 emails. We have 41 people that averaged 15.5 emails. We have 39 people that averaged 25.5 emails. We have 27 people that averaged 35.5 emails. We have 24 people that averaged 45.5 emails. And we have 22 that averaged 55.5 emails. Okay, so now what we're going to do is we're just going to type those right into our calculator. So I go to my calculator, I hit stat, I go edit, and I'm going to clear out list one. So I go up to list one and hit clear. Now, list one is going to be the number or the number of emails, okay? So this first one was 5 emails. The next one is 15.5. The next one is 25.5. The next one is 35.5, 45.5, and 55.5. So now in list two is going to be the frequency. So there were 25 of them that had 5. There were 41 that had 15.5. There were 39 that had 25.5. 27 that had 35.5, and 24 that had 45.5, and finally 22 that had that. So now I have, these are the number of emails, this is the frequency that that happened. So what I do is I go to stat now, and I go to calculate, and I'm still going to do one variable stats. So again, I hit stat, I move it over to calculate, and then I choose one variable stats. It says list is list one, but now that second one says frequency list. Well, that's going to be L2. So if I hit alpha, no second, 2, that puts in L2. Okay, because that's in little blue letters above 2 says L2. And I hit calculate. And so it says the mean is 28.24. So that's the mean number of emails that each person receives is 28.24. And the median number of is 25.5. So the mean 28, the median is 25.5. So the mean is 28, the median is 25.5 emails per day. So this is the average number, this is the median number. You know, so if I put them in order, this would be the middle number. The mean is actually higher because of these pulling it up. Okay, so that's that question. The next question says, here's a chart of gas mileage for various cars. Compute the mean and the median. So all we're going to do is take these numbers and type them right into our calculator. So we go back to our calculator, we go stat, calculate, whoops, not calculate, edit first. I'm going to go up to L2 and clear that off, hit enter. Move over to L1, hit clear, and then enter. So now I'm going to type in the numbers, 43, 24, 30, 21, 36, and 16. So those are my numbers. I hit stat again, move it over to calculate one variable stats. I'm going to delete a frequency list. Hit enter. It says my mean is 28 and my median is 27. Okay, so I'll compute the mean and the median miles per gallon. So the median's 27, but because this 43 is up here, it pulls it up a little bit, okay? We have 16, 21, 24, 30, 36. Those are all fairly close, but then 43 pulls our average up a little. So that's how that works on that one. It says, suppose you must choose a high school for your child. You are interested in your child getting rich so that he or she can support you in your old age. Explain what you can deduce from statistics about the mean and the median of the incomes of graduates of various schools. Well, let's say you had a school that had a mean. No, let's say you had a median of this. but a mean of like 70,000. Okay. We could really go crazy, but we're just going to keep them small. Those aren't overly high for it by any means. You'd really want to choose something more like this. Um, and you'd really want these to be semi-close, or you'd even better be something like this. So let's talk about these, and let's talk about this one even. So what's happened on this one is the median, the middle number. So if I took all the people from so many years and said, what are they making salary-wise? And I put them in order, 50,000 is the middle, or 80,000, or 110, or 110. But it says the mean is 70,000. Well, the poll for the mean to be up here, it means we had a few people that were way up here. Okay, I mean these people were way up in dollars to really pull that up here. So this means we had some really high top end people. We also had a lot of bottom end people, probably more lower than these top people really. If the median is 50,000, then this to get the mean of 70,000 means we had a few people that were just phenomenal up here at the top. Probably like made $1 million or a couple million and pulled the average really far up there. This one, median and mean 80 to 85,000. That's pretty close. You know, that means that we still have a few top end people. So there's some people coming out of here that do pretty well. Now this one, the median's a little bit higher. So what that means is we've got a few low dollars that are pulling things down, but overall, 110,000 is 109 are really close. So we're saying the average and the median both are right around that. So this is looking pretty good as far as going to here and coming out getting a pretty good job. Okay, you might get some less, but you might get some more. But overall, you're going to end up in this 100,000 six-figure digit area. Now in this one, if the median is 110,000, but the mean is 75,000, that means there's people here that are like way down here in the bottom of the barrel, barely scraping to get by. And we don't have tons of people up to the top to really, you know, they're maybe 130,000, you know, or 150,000, but they're not enough to overset a whole bunch of these lower end salaries. So that's kind of what that means on that question. So now the next question says, the median is the best measure of central tendency when there is an outlier. That is true. The median isn't affected as much as the mean is. If you have an outlier either way high or way low, remember that really skews the mean. It pulls it up or down. The median is always less than the mean. That's false. I just showed you with that, the numbers on the dollars, how that would work. Give an example of a data set where the mean is greater than the median. Compute the mean and median for your data set. So I kind of gave you some ideas on that one. Give an example of a data set in which the median is greater than the mean. So, and it doesn't need to be very many. You could choose like 9 numbers and just figure out how to make those happen, you know, like 1, 1, 1, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. The median 1, 2, 3, 4, 5. There's my median number, and the mean is going to be way bigger because this 25 is really going to pull stuff up. Okay, when I go 25 and divide it by 9 just by itself is bigger than 2. So when I add this other stuff on and divide it by 9, the mean will definitely be bigger than that. So anyways, that's a section 2. Like I said, that's a major crash course. We highlighted a few things, the 68, 95, 99.7 rule. That's 1 standard deviation, 2 standard deviation, 3 standard deviation. We talked about what standard deviation is, how far off of average you are, based on the way things we find the average, and they say this is the standard amount that people are off of this average, and it's different for every person, or for every set of data, not for every person, for every set of data. So when I get a new set of data, the standard deviation is not going to be the same for this as it is for this one, okay? So standard deviation is a big one that we just learned about. We learned about a box and whisker charts. We learned about, not a box and whisker, this is a stem and leaf. We learned about a box and whisker chart, using your calculator to calculate the mean, the median, and then scrolling down, this will give you the minimum, quartile 1, the median, quartile 3, minimum and maximum, okay? We learned about a histogram, how these work. So this is the number of scores, or the number of people that got these scores, the number of cars that got this mile per gallon, whatever it is. This is normally your number, and this is like your test scores or something, okay? And these are always the same interval length, and they go next to each other. So anyways, we also talked about a normal bell graph, normal bell curve versus skewed to the left and skewed to the right. And we made our hairy llama looking dinosaur, snail, anteater, slug, whatever you want to call that thing. So anyways, that's what we covered in this. Like I said, it's a lot of stuff. So good luck with that, and hopefully I didn't confuse you completely.